Hi Year 10, today we're going to do a practical, a little activity where we're going to model how half-lives of radioactive elements work. So as you've been reading, radioactive elements randomly decay atom by atom, but when we have a larger volume, we can predict it and it's more mathematical. So today we're going to use some 100 M&Ms and we're going to flip them like 100 coins, and then we're going to do a graph to see the mathematical pattern for half-lives. Up here on the board I've got my table ready to take down results. I'm ready to talk about our graph. For our first run, our first flip, we're going to have notice down here in the column I've got the number of turns. That's how many times I flip these coins or flip these M&Ms. The undecayed ones, so either they're landing with the M's up or blank up. I'm going to say that the undecayed ones don't have the M's on them. No M's on the M&M. And then I'm going to do some maths to work out what percentage have decayed. So on our first turn, which is actually our 0th turn, we're going to have none undecayed, or sorry, all of them undecayed, 100 M&Ms decayed, and so 0% of them have decayed. And now on my turn 1, I'm going to put them all in a cup. Oops, and hopefully not lose them. Oh, that's not a good one. That's okay. Put them all in a cup, and then I'm going to shake them up, try to get it as random as possible, and put them in this tub. Alright, pour them all out. You can take a look. What do we say? The M's that are facing up are the ones who've decayed. So it's like we've just flipped 100 coins. So bear with me. I'm going to take the decayed ones out and put them in this cup. And then I'm going to count the ones that haven't. I'm trying to do this as quick as possible. That's a bit of a boring video, but you're understanding how I'm doing it. Maybe there's something I can talk about as I'm doing it. I don't know if I can multitask. I'll just ramble on like I usually do. You should be used to that by now. Alright, getting there. Well, some of these M's have faded. Alright. So it's a 50-50 chance whichever side they landed on, M's up or M's down. It's kind of like flipping a coin. Where was I going with that? Oh, it's kind of like the particles too. At any time, there's a chance that they could decay or they might not decay. So it's like a 50-50 chance. All right, I've removed all the ones with the M's up. They're the ones who've decayed. They've decayed into another isotope. So the undecayed ones, have a look. Can't see it. Oh, I can still see an M there. That's terrible, Mr. Roberts. All right, I'm going to count those and put it in my table. 3, 6, 9, 12, 15, 18, 20, 24, 28, 31, 33, 35, 37, 38, 40, 42, 44, 50, 52, 54. 54 have remained undecayed. So what percentage did decay on the first one? It must be, maths, 46 must have decayed. They must add up to 100, okay? We started with 100, so 46 decayed and we've got 54 left over. So that's turn 1. Now I'm going to do, with the ones that haven't decayed yet, I'm going to do another round. Put them back in the cup, shake them all up, and see how many decayed this time. Alright, there's my random roll. M's up, M's down. I'm going to pull out the M's up and put them in here. These are the ones that have decayed in this second time. Pulling out the M's. Oh, there wasn't too many. Oh, there's one more. Oh, and there's a green one. And there's a red and yellow one. Oh, these yellow ones are hard to see. There's 2 more yellow ones. And a blue one. Alright. Oh, hang on. There's 2 more here. Damn, these are very faded. Alright, there's what's left over. They're the undecayed ones after the second round. Now I'm going to count them. And we'll put them in our table. 5, 8, 11, 14, 16, 20, 23, 26, 29, 33. 33 are undecayed, so all up, the amount that has decayed must be 67. Does my maths add up? Yep,
Yeah.
those 2 add up to 100. That's good. Thanks, Mr. Gallagher.
Anytime.
Alright, put them back in. We're up to round 3. Give them a good shake, the ones that haven't decayed yet. Put them all out. It's getting less and less, isn't it? Alright, pull out the M's up. Put them in my decayed bucket. There's a yellow one, a blue one, a green one, a red one. Oh, I think I'm nearly there. Oh, that yellow one is an M up. There we go. That's what's left over after round 3. That's what hasn't decayed. Oh, I've got to count them now. I'm just going to put it back in the cup. 3, 6, 9, 11, 14, 17, 18, 19. We got 19 after that round. 19 that haven't decayed. So that must be 81. Yep, that adds up to 100. 81% has decayed. Round number 4. You should be able to see a pattern forming now. Oh, give it another shake. Alright, here's my new coin flip for all those leftover ones. Pull out the M's up. Oh, there's quite a few actually. And that one. Alright, that's how much we got left over. Not much. Alright, that is 8. Yep, 8. 8 after round 4. So the percentage that must have decayed would be 92. So they add up to 100. Round number 5. Put our 8 back in. Give them a random shake. Take a look what happened. I think there's 3 or 4 with them up. 3, they're all down. Okay, so count them again. I've got 1, 2, 3, 4, 5 left over. So 95 must have decayed by this point. What round are we up to? Round 6. Alright, there's 1 and there's 2. So we've got 3 undecayed still. Oh, was that too quick?
Yeah, it'll be right. They can trust you.
They can trust me. Trust me. Why would I lie to you? 3 back in here. Alright. There we go. There's the results from our 3. So pull out the 2 that were M face up. We've got 1 left after round 7. So 99% have decayed. Let's just check there's an M on that side. Yep. Alright. Put 1 back in there. Alright, and there's the M up. There's the M up. There's our last one decayed. Alright, so after round 8, we've got 0 and 100% have decayed. I made some extra room just in case. Okay, what you need to do at home is graph this. Now, graph paper if you have some. If not, use Excel or use Google
Sheets.
Sheets, thank you. Or there's also a Apple one, not an Apple, Numbers or something. Use one of those spreadsheet programs. Put these numbers in. Let's first identify our independent variable. What did we deliberately change? We deliberately changed the number of times that we're randomly throwing these coins or these MMs. So it's the turn number is the independent variable. So that, the independent variable, I've got this around the wrong way, haven't I? Embarrassing. The independent variable always goes along the x-axis. Terrible. So that will go along the bottom here. So divided evenly, we've got 8, well, sorry, we haven't got 8 rounds, we've got 8 rounds plus the 0, so that's 9. So you want them 9 equally spaces, and that's your number of turns along the x-axis. And our dependent variable is what we measured. What did we measure? The undecayed number, okay? I'll write that sideways as best I can. Undecayed number. All right, and the range there is 100 through 0. 0 is going to be down here, 100 is going to be up here, and then divide it down. Okay, oh, that's not 50, that's 50, that's 25. Okay, once you've got that set up on paper, I want you to plot those two numbers on there, and you'll get a very distinctive graph. If you're on Excel or a program, plot it out and plot your graph too. Make sure you've got axes titles, make sure you've got a title for it up here. What other convention? Make sure you've got definite data points in there, wherever they are. I think that should make a good graph. All right, thanks Year 10. Catch you next time.